Okay, let's try out Haskell programming, whatever this is. Okay, so this is an interactive tutorial I found by Chris Dunn, so thank you very much to him. Type help to start the tutorial. Okay. Help. Okay, so perhaps I should zoom in. To kick off, let's try some maths out. Up there, you can type in Haskell expressions. So try this out. So let's try 5 plus 7. And now do we have to put spaces between? We don't know. 12. Well done, you typed it perfect. You got back the number 12, just what we wanted. Let's try something completely different. Type in your name, like this. Well, my name is Josh, so I guess I should put it between quotation marks, right? And then press enter. Okay. Not what I was hoping for. Okay. All right, so you just have to literally just type in what he said. All right. Each time you're getting back the value of the expression. So far, just a number and a list of characters. You can have lists of other stuff too. Let's see your lottery numbers. 42, 13, 22. Those are his. So I'm going to do the first 3 primes. 2, 3, 5. Great. You made a list of numbers. If you win, we'll split the winnings, right? Let's see what you've learned so far. How to write maths and lists of things. You can do stuff with lists. Maybe you want the lottery numbers sorted in the right order. Okay, so as that's an ascending sequence, it's already sorted. So what we're going to do is we're going to sort a different list that's jumbled. So let's say the first 10 digits of pi. 1, 4, 1, 5, 9, 2, 6, 5, 3, 5. And we're going to see what happens. Press enter. Okay, so this is sort of looks like this. So what does it say here? It says num A ORed A goes to A. Congratulations, you just used a function. They're how you get things done in Haskell. Now, am I saying it correctly? Let's see. Haskell, okay. As you might have guessed, we got back that. Ever wanted an evil twin nemesis? Me too. Luckily, you can sort characters or strings in the same way as numbers. So let's sort my name. There it is, with the space character coming first, and the rest of it alphabetized. For Hujjal Ninosi. Watch out for him. You should keep their credentials for the police. My nemesis is 28 years of age. Okay, so I'm 36. Is 36 a normal age for a supervillain? You just wrote a tuple. It's a way to keep a bunch of values together in Haskell. You can put as many as you like in there. I see. So it's just a way of packaging up data like that. No. Okay. Right. So now, once we have a way to create sort of like a list of data where, let's see, there's a number in the first position and then a string of characters in the second position. Let's say we want the first element in the list. First element in the tuple. Let's say we want that. So let's see what this does. All right, brilliant. We get 36 back. Lesson 2 done. Wow, great. You got the age back from the tuple. Didn't even break a sweat, did you? The first function just gets the first value. It's called FST because it's used a lot in Haskell, so it really needs to be short. Time to take a rest and see what you've learned. Functions can be used on lists of any type. Okay. We can stuff values into tuples, and they seem to be of any size. Okay. Getting the values back from tuples is easy. Well, no, I don't agree. I can only get the very first value back in a tuple right now. Let's say you want to use a value more than once. How would you do it? To make our lives easier, we can say let x equals 4 in x times x. All right, let's see what that does. Presumably, is it going to say 16? Let's say, brilliant. You just bound a variable. That is, you bound x to the expression 4, and then you can write x in some code, which is called the body, and it will mean the same as if you had written 4. Let var equal expression in body. The in just separates the expression from the body. I get it. Okay, well, let's try this then. Well, that should be 160, right? Brilliant. Now let's say we want to get the age of the villain. We could do let villain equal that tuple right there in first villain. I see. Okay. So we're going to let my enemy is going to be called Gary, from Pokemon, Gary Oak. Let's see what this does. Right, now why did that work? So it picks up the tuple, puts it where villain is, and then it applies the function of first because it sort of like carries out what code is in the body. Now let's take a short detour to learn about syntactic sugar. Try typing this out. A. Okay. A in single quotation marks is equal to square brackets like that. Press enter. You constructed a list. Well done. That was tricky syntax. You use the colon function. It takes two values, some value and a list, and constructs a new list out of them. We call it cons for short. Okay, so that's a list. So the colon symbol is literally a list constructor, an empty list. So we can use. All right. So well, what I'm going to do right now is just try it out. Like, I see. Right. Okay. So you have to have some other stuff around. I'm going to ask Gemini to. Okay. Main IO and then brackets. Right. I don't need to know what that means right now, but I do know that main. All right. How about that then? Okay, great. So now I want to test this. So what happens if I just put that there then? Does it break or not? Well, it does. All right, fine. Okay. So just create a sort of a dummy list here. No, it doesn't like that either. Right, try and remember what I did. All right. This doesn't work how I think things work. Right, so let's just do something after this, yes? All right, so you're not allowed to declare that twice, I see. Okay, main equals do, and now do this. All right, that's how to do that then. You have to say main equals do, and then you have your instructions underneath. It appears. Let numbers equal this. Let names equal this. All right, so let's see what happens when we print out a list. Okay, it doesn't protest against that. All right, no, it does that. Now, here it is, the cons operator. In Haskell, a list is actually a linked list under the hood. You can build a list by constructing it. Okay, so there's a bunch of stuff to learn about this, and I will learn it all then. Dot dot gives me that. Dot dot gives me that. But the third one is what Oh, man. Really doesn't like that. Wow. Why? I do. Can you do that? No. You just don't like it. Wow. Can I do that? Is it because they're not the same type? Okay, now you like it. Okay. Okay. Ooh, okay. Right, we got it. So that was quite cool. So we want to be honest though and continue with his ideas here. Okay, so true. It is true that that character and that character shoved into that list is equal to that. Now, to make things nice and easy, tell me, is it true that A, B, then C, that list of characters there, is that in fact equal to A, B, C, just like that? Is that true? That is true. Okay. Lesson 3 is over. All right, that was fun. Thank you.